we are good to go. So, before we get started, I'll mention that we have a Slack channel and it is dedicated to everything ML ops, everything machine learning operations. So, if you are not in the Slack channel, I will throw in a link to that in a minute in the chat so that you can join us. It's good to have you all here with us. and um, and so, yeah, what do we do in the Slack channel? We share machine learning stuff. We share a lot of stuff about architecture and different machine learning pipelines, tools, everything that you could want to know if you're getting into ML ops. And we also share all these past meetups. And sometimes people make fun of me. They ask me how many different kinds of coronaviruses I have hiding in my beard, or they make fun of my long hair. And that's totally fair game too. If you want to do it that way, that's all good. But mainly, there's a lot of smart people in the Slack. So feel free to join. I'm going to share the link with you so you can get in and have a play if you want. And so now, to start us off, we have none other than Robert Munro. He is here to talk to us about machine learning, human in the loop machine learning. And one thing that really struck me when I was doing a bit of research on Robert is that he has a very diverse background and he's very prolific in all of the things that he has done. One of them, we were just talking beforehand about how he went and he was working with the UN in Sierra Leone. And for me, it showed that, yeah, he's been able to just have cast a wide net and do many different things. And so he also told me, or I found, that he is a bike enthusiast and he's biked through which countries was it, Robert?
I've biked across 20 different countries. I could try and list them for you quickly.
Yeah, I think.
But I think we're on limited time here.
Yeah, that gives us a really good idea of what you have done and how many continents, just to be sure about that one.
You know, I've crossed every continent except Antarctica. That's the holdout.
Wow. All right. So that just gives you all an idea of what kind of man Robert is and what kind of caliber of a person we have on here. And when Trek Bicycles heard that we were going to be having a meetup with Robert, they said, hey, let's sponsor this meetup. And so now, as you can see here, this is probably similar to the bike you were riding on. And Trek Bicycles said, you know what? We have been having a hard time ever since Lance Armstrong was riding on our bikes. And then he came out and he was positive for doping. So we're trying to get back into the swing of things. So that's just a little plug.
I'm impressed that Trek brought up the whole doping scandal in their sponsorship deal. That's really open of them.
Yeah, they want to get past it. They're trying to get past it. So yeah, let's go out there and buy some Trek bicycles. If anybody's looking for a discount code, contact me afterwards. All right, so now enough of the jokes. Let's get into it. We have a lot to talk about when it comes to human in the loop machine learning. I want to talk first about how you got into tech, Robert, and how you went from being in this disaster relief, UN, all of that stuff. You travel in the world by bicycle, and then did you jump into machine learning, or what was that progression like?
Yeah, absolutely. So, I imagine a lot of people, I started my career as a software developer. So I studied computer science as an undergraduate and worked in a whole bunch of different places. Originally in Australia, where I'm from, originally. A couple of years in England. And then that took me to working as an engineer in West Africa for the UN's Refugee Commission and other orgs there, mainly in Sierra Leone and in Liberia. And studied AI as an undergraduate. And even published a couple of papers at machine learning conferences, but I did not expect my career to go in that direction. That was like a fun thing that that I studied that I thought had no practical value. And it was when I was in West Africa that I was working in a fairly remote refugee camp in Liberia on the border of Cote d'Ivoire, and we heard these rumors that from fresh conflict over the border, new refugees had come over and were in the next valley. We weren't able to go there. Would run into the militia on the way into the town that we're working in. So we didn't really want to kind of go and explore, and we couldn't work out over the couple of days that we were there. We were doing a solar installation at a health clinic. We couldn't work out over the couple of days that we were doing that installation whether it was 10 people or 10,000 people. And it was really frustrating because we were there in the town, like we had UN Refugee Commission on the side of our trucks. Everyone was coming up to us, and we really weren't able to help. We had to report back to the capital Monrovia and the main offices there and say, look, there's people here, but we don't know. And what was especially frustrating is that I had 5 bars of cell phone reception on my phone, which I don't have here in San Francisco today. And no doubt a lot of the same refugees would have had cell phones, probably bouncing their signals off the same towers. But even if they could do that, the kind of AI that we took for granted 15 years ago, like search engines and spam filtering, it wouldn't have worked in their languages. It probably still doesn't have a very good experience in their languages today. Certainly, there's no machine translation services. So there's a real gap in that we had successfully brought technology to a lot of the world, but all the smart services which were coming online weren't available in most of those languages. So that motivated me to pursue a career in machine learning. It took me from West Africa here to Silicon Valley, where I started a PhD focused on natural language processing applied to health and disaster response in low resource languages. And that was the start of my career in machine learning. Oh, I think you're on mute just there, Demetrius.
Thanks for letting me know. What an amazing story. This is incredible. I am so excited to talk more about this. And like I told you beforehand, we could talk about that for an hour if but that's not what we came here to do. We want to talk more about human in the loop. And for anybody
Right.
that doesn't know, Robert's got a book out on human in the loop. Machine learning. I'm going to put that in the chat right now too so that you know, but I'm wondering before we jump like deep into that book, I would like to know what kind of tooling are you using when you are looking at human in the loop machine learning? Is it different than normal machine learning?
It's a lot of the same tools. I think you'll find that most of the time when you look at machine learning in industry, it is some form of human in the loop machine learning. So probably 90% of deployed machine learning systems out there get better with more human data. And most people who are using supervised learning or lightly supervised learning um, are looking at smart ways to annotate more data and then update their machine learning models. So I'd say most people are doing it. It's just the level of sophistication varies. You'll find just a lot of people kind of reinventing a lot of the same techniques because while everyone gets taught how to build algorithms in their academic or online courses for machine learning, not many people get taught how to prepare data, how to interpret uncertainty in your model, and all the other component pieces that come into optimizing the human side of supervised learning.
Mm. And so talking about this annotating data, do you outsource it? Is that something that you will typically do like on Mechanical Turk and that kind of thing? Or is it all done in-house? How does that work?
Yeah, there's different kinds of workforces that you might engage. So in my book, I roughly break them down into 3 kinds of workforces. One are in-house people who are typically subject matter experts, although that's not necessarily the case. And so they're typically very limited pool, maybe employed by the hour. At the other extreme, you have paid per task gig workers or crowdsourced workers like Mechanical Turk and other platforms like that. And then the largest growing group is something in between. It's outsourced workers who are specialists in annotating data. And so until about a year ago, I was CTO of the largest data labeling company, and this was our largest growing workforce. So these are people who are spend all day, sometimes specializing just in one type of data. So annotating videos for autonomous vehicles, or annotating certain kinds of text for sentiment or entities or other kinds of labels. And so that's a really interesting way that the economy of AI has changed, because by some measures, the majority of people employed in artificial intelligence today are the people doing the data labeling, not building the algorithms. But it's a really overlooked workforce in the machine learning
Hmm.
community.
Interesting. Yeah, we hear a lot about how the majority of the time the work comes in when you're labeling or you're cleaning the data, and that is where 80% of the work comes in, and then the fun part of building the models is just a sliver.
I agree with all of that, except that the fun part is not also the data part. I think yeah, I mean, I think done correctly, good quality control for annotation, thinking about the right guidelines, the right quality control, the right way that you can integrate machine learning and humans closely, is super exciting because it's answering what I think is the most important problem in technology today. How do humans and smart machines work together to solve problems? And so I think if, like a lot of us, myself included, when I first became a data scientist, and I thought it was all about the algorithms, I think if you can get get over the bias that the data is just there and ready for you to start building your models, and appreciate that the process of creating that data is super exciting, then you're going to have a lot better time in general as a data scientist in your career, because because that's what you're going to spend your time doing.
Yeah, it's about the journey, right? You know better than anyone. that's that's what it comes to. So there is something that you said um in your I think it was the blog post, how we're reinventing. It's like you're reinventing the same active learning strategies too often, and you repeat the same avoidable errors. And I'm
Right.
wondering, what are these errors that you're speaking of? What is something that we can learn not to repeat?
Yeah, absolutely. So, at first, for people who don't know what active learning is, active learning is the process of identifying what data is currently not labeled and needs a human label. So, to give a concrete example, let's say you're applying topics to news articles using machine learning. You have tens of millions of news articles which don't currently have a topic. You maybe have a couple of thousand which have been labeled for a topic. How do you then select, let's say the next thousand that you want to put in front of a human? If you randomly selected the next thousand, it may be that 90% of news articles are about just one topic, about politics, and so it's not going to be very accurate to do that. 90% from one very prolific news agency. So again, you're just lacking in the diversity that you want. And so active learning is the set of algorithms and methods that you will use to select the optimal unlabeled items to put in front of human for review. And so there's a couple of things that people often get wrong, or suboptimal, and one's interpreting uncertainty. So if you have a typical classification algorithm, softmax output, for anything beyond a binary task, there's multiple different ways that you can interpret what is the most uncertain. Where is your model the most confused, and put that in front of a human for review. And so a lot of the time, I've seen people maybe not realize this. They only look at the difference between the most confident prediction and 100% confident. Whereas actually, you can also look at the ratio or the difference between the most confident and the next most confident. You can use entropy to look at the difference between all the predictions and a completely flat prediction. And other methods with ensemble methods or dropouts get multiple predictions and look at the variance, often called Bayesian deep learning. These are relatively simple methods. I introduced them all in my book. The code for most of them is a dozen lines of code at most. And I also share open source PyTorch implementations of them all. So they're not necessarily complicated. It's just that they're not on people's radar, and not being aware that there's different ways to calculate uncertainty means that people try just one, rather than experiment with different ones to work out which is best for their data. And then you're sampling in a suboptimal way, maybe in a way that will perpetuate bias in your data, and so you'll be in a worse position than if you're randomly sampling. So that's one example of uncertainty sampling, which is very narrowly defined. It's like, where is your model confused? How can we sample more of those items? And then the other set of methods I mentioned, diversity sampling, are more complicated. So this is, what is your model missing today? Your model might be confidently classifying something but getting it wrong. What is the reason for that? Is it because it hasn't seen something before? Is it because your data is shifting? So it's a case of domain adaptation. And again, there's a whole set of standard, well-defined metrics for diversity sampling. But because it's not taught in a lot of academic courses, or it's not in a lot of machine learning books, it tends to get hacked together from scratch in a lot of different companies.
That's great. And I'm wondering, it seems like you're a big proponent of PyTorch. Is there a reason for that?
Oh, not in particular. Almost because I was opposite for a while. So I was familiar with TensorFlow and had been building TensorFlow models for a while, since before Keras made it a lot easier to experiment with TensorFlow. It was because I was already familiar with TensorFlow and Keras, and I wasn't with PyTorch. That when I sat down to write the book, purely for myself, I thought, well, this would be a great excuse to teach myself PyTorch. It was also timed with the rise of PyTorch. My old research group, the Stanford Natural Language Processing group, was starting to adopt PyTorch. And an old colleague of mine from when I was at AWS was running product for PyTorch. So these were purely based on my personal experience. And that's why I ended up in my book. TensorFlow is equally as good as PyTorch for human in the loop machine learning.
And I'm wondering, like, you talk about state of the art human in the loop machine learning, and what does that look like in your eyes? What is that like optimal way of doing it?
Right. So state of the art human in the loop machine learning today optimizes every part of the human in the loop cycle concurrently. So your active learning strategy takes into account what kind of workforce and what kind of quality control you're going to use when you later label that data. You might sample different data if you have non-expert crowdsourced workers versus subject matter experts working in-house. Similarly, the model that you ship, for one, you want to be able to interpret that model well. You might go for less overall accuracy. If it means, in turn, you can know your model confidence with much more precision. And also, with state-of-the-art models, you can incorporate uncertainty in the human labels into those models. So a lot of the time, we're taking all the labels for our data and treating them as absolutely accurate, when we know, in fact, that all our labels are noisy to some degree. And so you can, in some simple, some more sophisticated ways, incorporate that uncertainty into the models. And so in this entire cycle of sampling data, getting new human annotation, and then updating and deploying the machine learning model, you're making decisions about that architecture and flow, taking the entire system into account.
And how are you making sure that the human error rate is accurate? Is it like, because I imagine if somebody's
Yep.
sitting there labeling at it's the end of the night, they're tired, they're going to be much worse at labeling than if it was fresh coffee morning kind of thing.
Right, right. Yeah, so there's two ways to there's two common ways to evaluate human accuracy, which I spend most of the time on in the book, and then a whole bunch of like kind of fun, more cutting edge ways. The two most common ways are a reference to ground truth data. So you have some set of answers for which you already know the correct label, and you're embedding those among the new ones that the person is labeling. So maybe, 1 in every 10, 1 in every 100 is something you already know the answer for. And you can judge the accuracy of an individual annotator based on that ground truth data. And then the second is agreement. So you can give the same task to multiple people and look at how often they agree with each other relative to just like random chance agreement, given the number of labels. And so those are at a very high level, the two approaches. And then you can use them in combination as well. You obviously can get agreement across a larger amount of data. It's expensive to get ground truth labels. However, there are actually times where you want people to disagree. If there are a diversity of good responses, which are valid, then disagreement is a good thing. And so for that and other reasons, you want a little bit of ground truth data to be able to calibrate how you calculate agreement. And there's a bunch of methods for looking at inter-annotator agreement and combining that with ground truth. And they're not that complicated, but I like to say that most machine learning architectures are really just a bunch of high school math, which have been taped together in really clever ways. It's like kind of linear algebra and really smart architectures. And quality control for human annotation is a bunch of first year college math, still taped together in really clever ways. So it's like, it's knowable, but actually it's a little bit more complicated than the math that goes into the machine learning side of things.
That's great. Now, going back a little bit to this idea of data scientists that clean their data and they annotate their data, and that being 80% of their work and enjoying that journey, do you feel like that will ever change? Is there ever going to be a time when we won't have to do that? Or do you see that always being a part?
I think it'll always be a part. We certainly have better tooling to make that more efficient. But I mean, for one, the data itself is just inherently noisy, right? It's mostly human generated data that we look at for most of the problems, or something which has human involvement. That's obviously the case in text and speech and then sign languages. And it's also true for a lot of computer vision examples. People are making choices about where to put a camera. The resolution of cameras change over time. You get a lot of artifacts of sample rate and then all kinds of decisions that humans are making about how the data is collected. And so it's just really hard to get away from that and fully automate making that data fair and clean before that we can start building models on it. So that's on the data source side of things. Also, I'm not sure you'd want to get rid of human analysis of data in its entirety. I think pretty much every experienced data scientist would tell you they spend a lot of the time looking at the data but before they think about their annotation strategy or their model design. That'll give the intuition about what's easy, what's hard, what kind of architecture. Is it really a needle in the haystack problem? So maybe you want an information retrieval architecture rather than a classification architecture. And so I think looking at the data is always going to be valuable. However, we are getting better tooling to make that more efficient, which is exciting.
Yeah. Now, can you talk to us a bit about how important it is to build trust in the machine learning models?
Yeah. So if you can't trust your machine learning model, you don't know when it's right or when it's wrong, actually really limits the amount of use cases that you can deploy it for. So like I said, like most machine learning models out there, they need to know when to back off to a human. For example, they need to know when they're wrong, when they don't know something. So just think of something about your like your in-home device when it recognizes your voice. The saying it doesn't understand a command is way better than doing the wrong action. And so it has to have a notion of uncertainty built into it. And the same is true on the data labeling side of things. You need to be able to know when your model is uncertain in order to drill down in those particular areas of uncertainty and hopefully be able to correct those with the right additional data. And that's true for computer vision examples as well. So I've worked with a lot of autonomous vehicle companies, and obviously having the automated systems know when to back off to a human, and thinking about the right user experience to say, hey, you take control of this car or this helicopter or this boat or this tractor, which are all actual use cases I've worked on before.
Very
That's super
important.
important as well. Yeah. So again, I think this is another example of where there's a little bit of disconnect between academia and real world machine learning. Most academic benchmarks look purely at accuracy. and don't even take into account some measures that also include confidence, like AUC, area under receivership operating curve.
Mm. And now I was talking to a friend, David. Shout out to him because he wanted me to ask this question about, like, he's working at benevolent AI right now, and what he was mentioning is that they work with a lot of actual scientists, actual scientists, and he was saying that they come in and they'll really poke at his models, and he wants that, but he has to, like, it's almost like they're doing logic chopping around it, and he's wondering how can you get buy-in from the scientists and when you're working on these machine learning models, and how can there be like that cultural fit in a way.
Right. So, is the question, how do you get buy-in from the scientists who are particularly interested in the algorithm side of things?
Yeah, and they're interested in, yeah, exactly, the algorithm. They're interested in what's going on, why it's making these decisions. They're really coming at it from this empirical, like, what is happening? Are you sure about this? Is this a good theory? That way of looking at it.
Yeah, so I mean, I think if someone's really algorithm focused, then we haven't covered them yet in the talk, but a lot of the most sophisticated methods for quality control, for human annotation, for active learning, they actually use machine learning models themselves. So if you have a disagreement between humans about what a label should be, anything beyond two humans becomes an intractable problem. There's no simple heuristic that can help you arrive at the confidence that you should have in that human label. And so this is actually best posed as a machine learning task in itself. So, okay, given the historical accuracy of these three people, their disagreeing predictions across the labels, maybe demographic information if there is some subjectivity, or the background of the annotators might affect their the particular choice of annotation. This all becomes relevant information that you can then apply. And you don't necessarily need complicated models either. You can have like simple models which are more interpretable. Even single layer models, bringing together just a lot of this disparate information for good interpretability, or Bayesian models for that matter. And I have examples of all in my book. And so that way, I think it kills both those birds in that you can turn annotation and active learning into fun machine learning tasks in their own right, where it's more of a greenfield because less people have studied it. And then, especially with the simpler models applied to these kinds of tasks, it brings that empirical rigor. So rather than having a hand-tuned heuristic based on your instinct, you're actually taking a data-driven approach to these different human-in-the-loop tasks.
Yeah, it's quite interesting that it would be get a machine learning model to decide what machine learning models actually are doing, and who's on the right side of things.
Oh yeah, yeah. I mean, when I've built data for companies in the past, I might have had like half a dozen different machine learning models at different parts of that pipeline, just to create a data set so that they can start again and build on that data set. Yeah.
Yeah, and now can you talk to us a little bit about how shipping static machine learning models is different from shipping these human in the loop machine learning models?
Yeah, yeah. So one of the biggest differences, which people will find when they're coming from academia or into an industry for the first time, is how much more you need to think about retraining your model as more data comes in. So you might be able to get state of the art in a model that takes 3 weeks to train after you're happy with your hyperparameters. But if you're continually updating the data for your model and you need your model to be up to date. So for example, let's return to our example of classifying the topics of news headlines. If your model is always 3 weeks out of date, anytime there's new kinds of information in the news, your model's not going to be very accurate very quickly. And so this is a great example of when you need to think about your entire strategy for human in the loop machine learning, because you're going to have a model that is able to retrain, or at least retrain some of the layers really, really quickly to adapt to new data. And that solution might be having a model that is simple to begin with, and you're relying on data more than the algorithm itself to do the heavy lifting. You might have a more complicated model, and you've worked out what subset of parameters you can retrain, freezing the rest, so that you can update quickly. Or you might have ensemble models. So you might have a constantly retraining in a 3-week cadence model. And then for everything that comes within that training period, a simpler model. And then you're looking at the delta between those two. So there's different architectures that you might think about purely on the model side as well. And then your cadence for updating will also determine your annotation strategy. If you can provide near real-time updates for your model, then you want near real-time human annotation on new data as it comes in. And that pipeline looks very different for if you decide for your use case, you know what, it is fine just to batch things 3 weeks at a time. And in that case, you can treat your annotation in batches. And that'll also then affect what kind of workforces that you can efficiently engage, what kinds of quality controls in turn. So needless to say, updating a model every 3 weeks versus continual updating has huge implications on the upside for what kind of infrastructure you need, how you need to scale out, and what kind of monitoring you need on top of that.
And now, forgive me if this is a bit of a noob question, but I'm wondering how long it actually takes people to be, and how big of data sets are you talking about here? When you've gone in, how much time is spent on this annotation? And especially if you're doing it, if you're batching it every 3 weeks compared to this real time data annotation, what do those look like? And how much time is there? Just a few people that's their complete job?
Yeah, it really varies. Like some of the companies I'm working with now, there's barely any human involvement. It's a few hours a week. For others, they probably have the equivalent of hundreds of people always working in parallel, annotating their data. It's for an autonomous vehicle use case. So it's really varied. And again, like very different kind of infrastructure and ability to update. Though interesting in those two cases, the one that requires very light supervision is real time, whereas the one with a ridiculous amount of people doing annotation, they only update their models every few months. Although this is currently a company that's in an R&D stage for autonomous vehicles.
Hmm.
That could change a lot when they start deploying a lot of these models.
Hmm. And now, will you walk us through what exactly, when you're brought on to work with a company, what does that look like? Do they want you just to advise and tell them how to do it, or are you getting in there and annotating data also? How does that look?
Yeah, so I love to annotate data myself. I try to get everyone involved in a project
I had a
in
hunch.
annotating
I
data.
had a hunch
Uh,
that you did.
and it's something that can be fun within a company. So if you work in a company that does AI, you can run like what I'd call it annotation hour. Everyone gets together, and you don't have to have a technical background to do this. So it's a really good team building exercise. Sit there for an hour, annotate at the same time, share your thoughts about weird edge cases or just funny data that you come across. And it's a really nice way for non-technical people in your company to feel like they've contributed to AI. And the nice thing is they've definitely contributed. Like more labeled data is going to be helpful. Most of the trial and error you do building algorithms doesn't help. It's mostly error. Yeah, I find that to be a good positive way, as well as giving everyone an intuition about what data is going through the system. So when I come on to help companies, yeah, that just really depends on the engagement. I tended not to get too technical recently. I've been mostly in executive roles, and I think good executives don't try to jump into the code, at least in recent years. So for me, it's fun that I'm doing this in PyTorch, and it keeps my skills up to date. But it's not something I'm going in and doing. I'm advising people more on the strategy front, like what set of human in the loop machine learning algorithms they should be considering, what active learning is probably the best place to start for them, how to experiment to work out what would be a better active learning solution, what workforces are available, that will be more or less suited for their particular task. And then product strategy. How can you communicate the automation that you're bringing to your company, often for the first time, in the companies I'm working with? And how can you present that to your end customer without using the word machine learning? Because if you have to explain the underlying technology rather than the problem that you're solving for them, then you're probably not thinking about your product in the right way in the first place.
Hmm. That's so interesting to think about. Yeah, and it's a great point too. So, will you give us a few use cases of a company that you've gone into? You don't have to name any names, but just what it looked like and how you implemented and how you scaled too, because I know that's something that you wanted to talk about is scaling this whole human in the loop and with machine learning. And also, if anyone has any questions, feel free to throw them in the chat or take yourself off the mic and ask them. But yeah, can you give us a few use cases?
Yeah, absolutely. So I mean, I'll give one very current one. So the World Health Organization have a WhatsApp application for information about COVID right now. So in a couple of dozen countries worldwide, you can basically become friends with World Health Organization on WhatsApp, get announcement, respond to surveys at the moment, just typing like 1, 2, 3, and 4, nothing sophisticated. And increasingly, and also country dependent, asking plain text questions. And then there's like a sea of like customer service representatives who can respond to that in the various languages. So the people running that reach out to me for help because they're deploying this in dozens of different languages. And obviously, like this is an area I've worked in. My PhD was about healthcare and disaster response in low resource languages. And yeah, and they're taking a really sensible approach. So thinking about the customer service side of things, not immediately trying to ship a chatbot, because like the cost of any error is just terrible, right? You're giving people healthcare advice, so you really want a human in the loop for quality of data. And so then what they're thinking about looking at is just exploratory data analysis to begin with. So what does our data look like? How can I lightly supervise this interesting topic? This isn't. So they can understand what people are communicating. So this is like one human in the loop method for enabling subject matter experts to drill down and understand what's in the data. And then looking forward to chatbot, initially starting by enabling the customer service representatives. And actually, I'm working on a few COVID things which are just like this right now. Also, another project looking at misinformation. And so this use case is you've got a person who might be answering an answer via text. The question comes in, and then they get, say, 5 to 10 potential responses. So here are 5 to 10 things that might be the right response. And so as the customer service representative, it's quicker to view one of those 10 and click on it than it is to type things out. So it scales their work. And then if you do this correctly, and if you have not just relevance, but also diversity in those 10 that they're viewing, there might be a better response than the one that they were currently thinking of. And so they're able to choose that too. So this enables you to improve both the efficiency and the accuracy of the humans using machine learning without dropping that human level accuracy for the end user who wants that COVID information. And then now that you have that feedback, you have that human expert clicking one of those 10. That enables you to start collecting that training data, which maybe down the line could be used to start automating some of this in a chatbot. So this is this kind of framework and an approach is really common for me going into companies. It's starting by enabling humans as a stepping stone towards full automation.
Wow, that's so cool. And I love that you're it's coming full circle back to what we talked about at the beginning, how you saw this problem and you were on this working in the UN and realized that the technology wasn't there. And now you're actually using technology to do good with it. And so I'm wondering also, what can you talk a little bit more about what the misinformation use case is with
Oh
COVID?
yeah, sure. So this is a service aimed anyone can use it, but it's aimed primarily at journalists. So if they receive a piece of information that they're not certain about, whether it's like text or video or an image, they can send it to this service, actually again via WhatsApp, um, and get that response like, hey, has this been verified, or has this previously been proven to be misinformation? And so again, it's a manual service right now, and they're looking to semi-automate that. So again, in a smart way, bringing up the closest possible answers for a human to verify, looking for further automation later.
Wow. Yeah. And the stakes are so high in this kind of stuff.
Yeah, yeah.
So,
Yeah, I mean uh, the potential dangers for misinformation will exceed those for COVID itself in some areas. It's something I've seen in the past when I was working helping with Ebola outbreak in West Africa a few years ago, and in countries where I lived before. Um, we found that because of misinformation or information that was correct but exaggerated, or it's even put out in the wrong language, which scared people, more people died from avoiding clinics than from Ebola itself. So that more people died from other preventable illnesses than from Ebola by a factor of 10. And so it's something we're really worried about in a lot of the world at the moment, where food security is a bigger issue than COVID itself right now.
wow. Yeah. That is scary to think about. And we all have seen it. We've all clicked on something that may or may
Yeah,
not have been true. So I think it hits home to all of us. And
yeah.
so I also would like to know, since we're on this topic, have you seen a big blunder happen when it comes to this? Like a machine learning model that is high stakes. I guess any machine learning model these days can be considered high stakes pretty much. And so, have you seen one go wrong and go horribly wrong?
Um, Not in a way that greatly affected people's lives. Happily, mostly because they're cut off at the pass. But certainly, there are so many people I've seen try to release their own COVID prediction models, especially people here in Silicon Valley. And I mean, I've worked in healthcare machine learning for years. I was CTO of an epidemic tracking company, but I don't attempt epidemiological models. I'm not trained in how to build these models. I know enough about how they work to know that I can do data prep for them. I can do the so-called boring data normalization and validation and some of the annotation. But I wouldn't attempt those prediction models. And so I think there's none that I've seen like be incredibly dangerous, but like a lot of like well-meaning, but completely out of their depth and I'd say entitled Silicon Valley folk come up with their own explanations for epidemiological tracking. Oh, actually, yeah. Actually, there is one thing that's been a little bit dangerous is there's a movement trying to claim that homemade face coverings would prevent 99% of cases of COVID. It was like a crackpot here in Silicon Valley who had previously claimed to have solved medical imaging, but got a lot of movement behind it. Got a lot of troll bots behind it. It had some inadvertently racist messages, and so I think it was a good warning of how uh, anyone trying to step into a domain in which they don't have expertise, that it can lead to erroneous results from the model itself. And they're often stepping into a political domain that they maybe not be familiar with, and can become a part of someone else's propaganda machine.
Yeah, we don't like to get political on this, but that sounded a lot like Trump built a model and he put it out there. So
As far as I know, the U.S. government had nothing to do with this one.
going back to your book, you talk about this difference and the imbalance of academia and industry and how you've seen these two play out. And I know that a lot of people come from boot camps or whatever, they come from learning machine learning or data science, and everything is given to them, or they do some
Yeah,
Kaggle contest, and things are very clear and they're given to them. But then when you get into the real world, it's a much different story. And so, can you talk to us about how learning this state of the art algorithms and what you're doing in PhD world, it differs so much from what you're doing in the industry?
Yeah, I absolutely. And I will give a shout out. There are some courses out there that do teach you good data habits. So I've no like investment in Udacity, but I helped them with one of their courses. So if you took their data science nano degree, you'll see it's a disaster response data set that I helped them create, and I can give an interview that's part of that coursework. And it was with data taken from multiple different disasters in slightly different formats. And when I gave it to them, it was cleaned a little bit already. And they said, "How can we make this messier?" Which I thought was great. The only time any company's done that to me, it's any educational company. It's normally the opposite.
So yeah,
And
you
so
went
they
backwards.
yeah. And so they definitely were conscious of this, and wanted to teach real world data science. That doesn't start with clean data. Um, yeah, I mean, so this has been one of the biggest differences is that most of the time people come out of these kind of courses and they don't have to think about data annotation, and I think it's someone else's problem. And they're rudely woken when they get to a company and there is no data annotation department, right? It's like it's all something that data science has to deal with. So I'd say that, yeah, I mean the biggest gap is having to annotate data, come up with evaluation frameworks, which aren't just simple accuracy measures, and think about quality control for human annotation. The second biggest is actually much more on the operation side of things. So how can we scale models? How can we distribute them? Actually, I'd love to give a shout out here for the best ML ops person I've ever worked with,
Yeah.
Ray Lai. When I came into be CTO of I was on Figure 8 since it's been acquired. Um, like a lot of startups, the database was sitting on one EC2 instance, and it was growing almost to overflow the instance. But thankfully, AWS kept increasing the maximum instance size, and we had to take this to be multi-region, multi-cloud, and on-premise at the same time as supporting real-time updating machine learning models for the first time. And so 100% Ray Lai was the person who figured out the path for getting us onto Kubernetes, making us multi-cloud, and then running on-premise, and scaling this machine learning architecture. So especially on a show dedicated to ops. I wanted to give him a shout out.
Yeah, for sure.
Obviously, my expertise is in the human in the loop and data annotation side. So I was just really privileged and in awe to work with someone who could solve those problems.
Well, thanks for telling us. Now I know who I'm going to try and get on the show next.
Oh, you
So
should absolutely.
yeah, that'll be cool. We'll talk later about that. So yeah, and now one thing that I wanted to ask, do you see yourself going back to Africa and trying to implement some of this that you've learned over the years?
Yeah, as a disaster responder, I've continued to work in Africa. So, like I said, I worked there in the Ebola outbreak. A couple of years ago, I partnered with a data labeling company in Nairobi, and the Red Cross and Translators Without Borders to create better data in Swahili. So we took some existing healthcare information in English, translated that into different variants of Swahili, and employed people to speak the Swahili pieces as well, and then made that data open source. So that means that anyone training speech recognition models can now do it on healthcare related data in Swahili. Anyone training machine translation models can now do it on healthcare related data. As I'm sure most people in listen to this show know, having in-domain data is incredibly important. If you just train on news articles, your models won't be useful for medical, whether that's translational speech recognition or any other natural language processing task. So yeah, just merely getting that data out there has hopefully helped a lot of companies now with COVID. This was a couple of years before COVID. So now we know at least for Swahili, we have better medical translation and speech recognition than we did previously. And that's one example of work in Africa. But I continue to advise and work on lots of different translation and NLP products worldwide.
Yeah, it's so cool to see you're using this for good, and in your own way, you're changing the world. So
Barely, but I'm trying.
yeah, yeah, I feel like it's a great start, and it's really a um, you're dedicating yourself to very noble causes, and I really appreciate that, and I think a lot of people in the world do. So uh, I have one more question. I want to make sure I give space to anyone if they have any questions. If you have not checked it out, I have in the links in the chat. I put the blog post about using PyTorch, and then also and you created a PyTorch library with that, didn't you?
That's right. So accompanying my book is open source PyTorch library. And then I've also published excerpts from my book a couple of times on the official PyTorch blog as well.
And I was going to tell everyone the link that I put about the book, you can get a lot of the book for free. It's pretty much everything up till the last two chapters. Am I correct on that?
Yeah, so the way my publisher works is that they publish chapters as they're written. So it's at Manning Publications. I've written 9 of the 12 chapters. I think 8 are online right now. You can get previews of all of them for free. Frankly, a lot of the good stuff is in the blog posts I put out there already. That might be enough for you. My goal is really for as many people as possible to learn these techniques. So absolutely, if you'd like to buy the book, I'd appreciate that, and I value any comments or feedback that people have. But yeah, like check out the blog posts and the open source code. There's a fair bit out there already.
Yeah, and I'll post them again because for people that are just coming in late, um, so that I see in the chat somebody's asking about
Yeah, it's
that.
pretty searchable as well. If you use your favorite search engine to look for human in the loop machine learning, my book will come up top. If you search my name, my website will come up top, and then you see links to Medium, where I post on my blog post,
There you
and
go.
GitHub as well.
And also, what I'll do if you're watching this in the future or you're listening in podcast land, I'll put all of the links in the description. And then I'm also going to link to that. It was the course you mentioned that was really good about.
Oh, yeah, the Udacity Nano degree who have used used disaster response data. Yeah, I would love for that too. I've done a lot of work trying to open source disaster response related data sets in the past, and including doing the cleaning. I'm prepared to make that concession if it gets people interested in this use case. So I do encourage people to use that in their research.
But just so we're clear, if you need data sets cleaned, do not send them to Robert. He loves it, but he's not going to do your work for you. So you know, he really enjoys it, and he's a great guy, but he's not cleaning your own data. So yeah,
I will.
now
I'll happily give you instructions on how you can do it yourself. Yeah.
there we go. And last question from me is, what's the best way to get in contact with you?
Yeah, you can find me on Twitter at www.rob, and active to professional connections on LinkedIn as well.
Great, great. Yeah, this has been a pleasure. I am so thankful that you did this with us, and really, it was for me. It was just very eye opening to hear about your life story, how you're using all of what you're learning for good. It's a model, and I hope that I can I can be a tenth of the man that you are, Robert. So my life will be complete.
That's very flattering. I appreciate that.
So yeah, and if we don't have anything else, I will let you go. I know you're a busy man. We'll be in touch about the next one, and trying to get can't remember his name. Key on here. Who was it that you said was the MLOps expert?
Oh, Ray Lai. I
Ray
will.
Ray Lai.
I will share his information with you afterwards. Yeah. Yeah.
Awesome. Awesome. And so if anybody would like to share this, you found use of this talk, um, then I'm going to put it on YouTube, and I'll send you all a email with that. Just check your inbox for something from me. and you'll have it on YouTube and podcast land, wherever you want to listen. And then you can also connect with Robert if you need to on LinkedIn, or follow him on Twitter at www.rob. Two W's there, right? Not
Right.
three.
Worldwide Rob. Yep.
Worldwide Rob. There it is. All right. Thanks again, Rob. I appreciate it.
All right. Thank you so much for having me today. I really enjoyed this conversation.
Yeah, it was really nice. Take care, everybody.